Bonjour, happy Thursday everybody. Today we are going to be looking at 3D shapes, ready for our lesson tomorrow, which is going to be about 2D representations of 3D shapes. And tomorrow's lesson isn't going to be a video from me, you've escaped me for the day. So let's get going. Just a quick bit of revision. We looked at, on Monday I believe, the word polygon, and I told you all the things that made up a polygon. So just have a think and see if you can remember what a polygon is. Okay, so a polygon was a two-dimensional shape. It was closed, which meant all the sides met. All sides were straight or are straight, and that's all of them. And it's got at least 3 sides and angles and vertices. 3 or more sides, angles and vertices. Excuse the handwriting. That really doesn't look like vertices, does it? Okay, so what we did learn was that a circle is not a polygon because the sides aren't straight. A semicircle is not a polygon because the sides aren't straight. So the sides must meet at a corner in order for it to be a polygon. So today we're going to be looking at this word, polyhedron. Do you think you can work out what a polyhedron is? Okay, a polyhedron, similar to a polygon, except this time we're looking at 3D. So it's like the 3D equivalent of a polygon. So polygon is 2D, polyhedron is 3D. And similarly to a polygon having straight sides, the polyhedron has to have straight edges and also flat faces. If you can't remember what the edges and the faces are, we're going to look at those in a second. And again, we've got to have corners or vertices rather than a point. And if you're not sure the difference, we will look at that in a second as well. So this is what makes a polyhedron. So a sphere, for example, like a ball shape. So if you've got a sphere, my beautiful shading on here. If you've got a sphere, that is not a polygon because it does not have straight edges and it does not have flat faces. So a sphere is not a polygon. Neither is a hemisphere, which is the half sphere. That is also not a polyhedron because it does not have, it has one flat face, but it doesn't have all flat faces and it doesn't have straight edges. There are others that aren't polyhedrons as well. So let's have a look at some properties, first of all, of 3D shapes, just to remind you what everything is called. So here we have a cube. And on this cube, we have the flat part, so the big flat parts. And on a cube, let's do that one in a different colour so you can see that one's different. On a cube, we've got 6 of them. If you think about a dice, the sides of the dice. In this picture, you can see 3. 1 is hidden underneath and 2 are hidden round the back. So it's got 6 of those flat parts, and those are called the faces. So they're called faces the same way your face is kind of big and flat, sort of. The faces of the shape are big and flat. I'm not saying your faces are flat. Okay, we've also got these. On a 2D shape, we might call them the sides. But on a 3D shape, they're not called sides because on a 3D shape, they're called edges. And the difference being, a 2D shape, they just go around the outside because it's a flat shape. Whereas on a 3D shape, two faces meet. So for this edge here, we've got a face here that meets and a face here that meets. So these, equivalent to the sides, are actually called edges rather than sides. They're called edges. And a cube, which has 6 faces, has 12 edges. We've got, and some of them are hard to find on this picture, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the other half of this face, 10, 11, and then around the back you've got one opposite this, 12. So there are 12 edges. And then the final thing to look at are the points where 3 edges meet. And those, as you already know, are called vertices. And on a cube, we have 8 vertices. You can see most of them here, 1, 2, 3, 4, 5, 6, 7, and then there's one hidden opposite this one on the far side. So there's one hidden there, so there are 8 vertices. Okay, so those are our main properties of a 3D shape. There are a couple of other things as well that I will talk to you about as we look at the types of 3D shape, or the different 3D shapes, because there's a couple of other words I want to teach you. But faces, edges and vertices are the main things to look at. So remember, faces are the flat parts, and for it to be a polyhedron, they've all got to be flat. So a sphere has one face that goes all the way around it, but it's not a polyhedron because it's not flat. The edges are where 2 faces meet, and the vertices is where 3 edges meet. Okay, here are some 3D shapes, and I've already given you the names of these ones. Can you work out for me and tell me which of these are polyhedron and which are not? Because there's a bit of a range. Remember what made a polyhedron. So we have here a tetrahedron, and that is, we've got all straight edges, all flat sides, it's 3D. Cuboid is. A sphere, no, is not. A cone is not. And if you remember earlier, do you remember I said the other thing about a polyhedron was that it had to meet, it had to have vertices rather than a point. This is a point. Because this face on the cone is not flat, so if you imagine like a traffic cone or an ice cream cone, it's not flat. So therefore, where they meet at the top is not a vertice, it's not a corner, it's a point. There are no edges to meet, and vertices has to be 3 or more edges, and there are no edges for a cone, so it's a point, not a corner. Bottom row, cylinder is not, because it's got a round face. A cube is, a triangular prism is, and a square-based pyramid is. Okay, couple of things I just want to talk about with these. One of that is what a prism is, and you will need this later on for the work that you're going to do for me later. Let me just move the sheet a little bit so I've given myself enough room. A prism, such as the triangular prism here, is if you were to cut that triangular prism anywhere along, so it might be here, might be here, might be here, as long as you cut straight down, unlike that middle cut, which I haven't done very well, as long as you cut straight down and you still see exactly the same face inside, it's a prism. So wherever I cut this triangular prism, I will always see that triangle. It's a bit like a stick of rock at the beach. When you see a stick of rock at the beach and it's got writing in it, wherever you cut, you still see that writing. That makes it a prism. So a cylinder is actually also a prism as well. A cuboid is a prism. A cube is a prism. The other ones are not, because if I cut my my square-based pyramid, let's say I'm cutting along here, the square that I see will get bigger and bigger and bigger, but it has to be exactly the same. This same on the tetrahedron, wherever I cut, the face will change. So that's not a prism. And the cone, I could cut it and get a bigger and bigger and bigger circle all the way down. So it's not a prism. So a prism is where you cut it and you see that exactly the same size and shape of the face. And that face that you see is called the cross section. So in a stick of rock, that writing that you see, and wherever you cut it, you will see it, that's called the cross section, because it's always the same. And that's what a prism is. You need to remember that because you'll need that later on. So on here, we've only got a triangular prism, but you can get all sorts of prisms. A square prism is actually a cube or a cuboid, because you can see here we've got the square that you'd always see. A circular prism is a cylinder. A rectangular prism is this cuboid. But you could also have, for example, let's try and draw it as best as I can, a hexagonal prism. So that prism, I'm not very good at drawing those, but that prism, you would always see the hexagon. So that's a hexagonal prism. You could get an octagonal prism where you'd always see an octagon. The triangular prism is the most common one, but you can get all sorts of prisms. The triangular prism is the one that looks like a Toblerone box. Something also just to point out, the tetrahedron, oh, I'm wrong button, that one. The tetrahedron, a tetrahedron is a particular type of triangular based pyramid. This one that I've drawn here is not a tetrahedron. And the difference is, on a tetrahedron, all the faces are equilateral triangles. This one that I've badly drawn down here, it's a triangular based pyramid, but because they're not all equilateral triangles, these two are isosceles, it's not a tetrahedron, it's just a triangular based pyramid. And of course then we've also got the square based pyramid. So a tetrahedron is a special kind of triangular based pyramid. Okay, I've given you lots of information there. Have a look at these two shapes here and think about what's the same and what's different. So we know from the last page that this one is a cube and this one is a cuboid. So just have a think to yourself, what's the same and what's different? And that is not one of the differences, that's got the black stock photo sign on it. Okay, so let's have a look and see if you've got any of these. So they all have the same number of faces, which, if you remember the big flat bits, they've all got 6 of those faces. Let's look at this one down here. All vertices are 90 degrees, which means they are right angles. All vertices are right angles. So on both shapes, the vertices are all 90 degrees. So every single edge meets at 90 degrees. They are all, can you remember the other word beginning with P? They are all perpendicular. Okay, so that's the same. So far that's the same and that's the same. I'm going to come over here. All the models are 3D. That means they have 3 dimensions. So they go up, they go across, and they also have depth. up, across, and also have depth. So they are both 3D. They have the same number of vertices, 8, and edges, 12. So that's something that's the same. There's an awful lot that's the same. So they've both got 12 edges, if you count all the hidden ones. And they've both got 8 vertices, again, if you count the hidden one that's behind the back. So that's the same on them both. Where should we go next? All edges are parallel. Another word we looked at earlier in the week. So this edge and this edge are parallel. This edge and this edge are parallel. This edge and this edge are parallel. Parallel, same over here. All those edges are parallel. And remember to show that, I put those arrows in like that to show they're all parallel. So that's something that's the same. There's very little that seems to be different. And yet I can definitely tell that they are different. All faces on a cube are square. Now this is where we start to get different. So on my cube, every single face is a square. They're both prisms, but on the cuboid, we've got rectangles. Sometimes you can have a cuboid that's got 2 squares and 4 rectangles. I haven't drawn that very well, have I? So this one would have a square either end and then 4 rectangles. But this pink one has got 6 rectangles that are all different. So it does depend on the cuboid, but that's something that is different. That on a cube, they're all square. Lengths and widths are the same in a cube. Sorry, I've ticked those two, and I shouldn't be ticking those two because they're something that's different. My apologies. So on a square, all of the edges are the same length. On a cuboid, we have different length edges. So the only thing that's different here are the shape of the faces, some being square, some being rectangles on the cube, or just all rectangles. On a cuboid, sorry, but on a cube, they're all squares. So I've now got a question for you to think about. Is the answer to this question always, sometimes, or never? A cuboid is also a cube. A cuboid is also a cube. Do you think that's always true, sometimes true, or never true? We can also think about this the other way around, actually. A cube is also a cuboid. Think back to when we said that a square is a rectangle, but a rectangle is not a square. A square is a special type of rectangle. The same is true with a cube and a cuboid. A cube is a cuboid. It meets all the criteria for a cuboid, but a cuboid is not a square because it might have rectangles. Whereas a cube does meet all of the criteria to be a cuboid as well. So a cube is a special type of cuboid, but not the other way round. So this original statement of a cuboid is also a cube could, I would say, be sometimes. If that cuboid is a cube, then yes, it is a cuboid. A cube also a cuboid, so the other way round is always true. It's a bit of a tricky one to get your head round. If this cuboid is a cube, then it is also a cube, so that could be sometimes. But if the cube is also a cuboid, that's always true, because a cube is always a cuboid. Bit of a tricky one to get your head round, so it depends which way you word it. Okay, this is the work I want you to do today. And it's some of them, this is why I had to speak about prisms earlier on. because you will need that knowledge. So this one, it's really just kind of using your eye and trying to imagine the shape. So this is a cube with a bit cut off of it, a corner's been cut off. So you've got to work out now how many faces and edges this new shape has got. A hexagonal base pyramid. So remember, we had a square base pyramid, we had a triangle base pyramid. This is a pyramid that the bottom of it is a hexagon, and then all these triangles will sit on the hexagon and will meet at their top point. So if you imagine those sort of leaning in towards each other, and they'll all meet at the top point, and that's your hexagonal pyramid, which I would attempt to draw. I'm not sure I can. It would sort of be... Okay, I knew I wasn't going to be able to draw it, so I found one for you. So this is a hexagonal base pyramid. This is what it would look like. So the question here is, how many edges does that have? Remember, the edges are the straight, sort of like the sides, but it's where the two faces meet. So this picture will actually help you really well to have a look at, to count the edges. A 3D shape has 5 faces and 9 edges. What is the shape? Now, what you could do for that is to whip back to here and see if any of those will help you out. So you're looking for a shape that's got 5 faces and 9 edges. Which of those is it? This sheet, by the way, you don't have to do it from this video. The sheet is in their website, in the files. Okay, which shapes below could make the faces of a rectangular prism? Now, a rectangular prism, I'm going to help you out here. I did say it earlier, is a cuboid. And do you remember we said that cuboids could have rectangles as their smaller faces, but they could also have squares. Okay, so I'm giving you some clues here. So some of these will make a cuboid, but some won't. Don't forget to think about the sizes of the squares and the rectangles as well. Could you have one, for example, where all 6 faces are the same rectangle exactly? Would that work? Have a think. Try and draw it. See if you think it will work. You could even try making it. Okay. Card glues 2 identical 3D shapes together. How many faces does this new shape have? So here's his new shape. You've got to imagine that shape and guess how many faces it's got. And there are some options here. Then you've got a bit of a maths challenge here. So if you get all that done quickly, draw a table and record how many faces and edges the following shapes have: cube, square base pyramid, and rectangular prism. Now on the website, the answers are on the second page, but don't look at them yet. There's no point just copying the answers straight off, but you can then mark it because they're on the second page on the website. So you'll find this sheet on the website, and then you can mark it yourself to see how you did. So you've got a lot of visualising to do today, and then tomorrow you're going to have a look at some nets, net, N-E-T, but do look at the work template, because it won't be a video tomorrow. So don't look for a video from, well, it might be a video, but it won't be a video from me. So look on the work template and there'll be a link to where I want you to go tomorrow. Okay, have fun doing this, and I will see you next week.